Hello, my wonderful students. Welcome back to my channel. So, today we are going to see class 6 mathematics chapter number 1, a very important chapter, which is integers. Okay, so we already know what is an integer. So, integer is any number that is including 0. So integer is any number which is including 0. Positive numbers, example like 2, 5, 6, 100, 1000, and negative numbers as well. -3, -20, -15, and integer includes both positive and negative numbers. Okay, and let's see what will not include an integer. For example, fractions, 5 by 21, or a decimal, 2.5 or 30.10, or another fraction, 15 by 21. So these fractions and decimals are not an integer. Okay, so you have to understand an integer is any number including 0, positive number and negative number. It should not be an integer, can never be a fraction or decimal as per cent. Okay. So let's see the properties of addition and subtraction of integer. So we have learned about whole number in integer class 6. We also learned about addition and subtraction in integers. So let's see closure under addition. So we have learned that sum of whole number is again a whole number. For example, 17 plus 24 is 41. So 41 is a whole number. So sum of whole number. So whole number, let me erase this and give you in a neat picture. Okay, so for example, sum of whole number plus whole number which is equal to whole number. So whole number plus whole number which gives you a whole number as well. That is the example they have given. So let's give one more example. For example, 10 is a whole number, and when you add 10 plus 20, which is another whole number, you get 30, which is another whole number. Okay, so we know this property is known as closure property for addition of the whole numbers. Okay, so these kind of questions you will get in 1 mark. Okay. So let's see. So let's see whether this property is true for integers or not. So they are checking whether it is a true for integers or not. Following are some pairs of integer, observing the following table and complete it. So let's complete this table. So we have statement and observation. So on the left hand side we have statement and right hand side we have observation. So first one is 17 plus 23. So 17 is a whole number, 23 is a whole number, and they both are integers as well. So 17 plus 23, which is equal to 40. So result is an integer. So 40 is an integer. Okay, so let's see the next one. So minus 10 plus 3. So what is minus 10 plus 3? So minus 10 plus 3. So minus, and we have plus 3, which is minus 7. So result is an integer. So here we can write integer. Okay. So next one is minus 75 plus 18. So minus 75 plus 18. So we have 7 minus 3, which is 5, 57. So it is 57. So we have the bigger symbol in negative sign. 75 is bigger number which has the negative symbol. So it's minus 59, 57, which is obviously an integer. Okay. And we have 19 plus minus 25. So we need to minus this. So 25 minus 19 is 6, and 25 has the negative symbol, and 25 is the largest number as well. So it carries minus 6, which is an integer as well. So next one. So 27 plus minus 27. So 27 minus 27, which is equal to 0, which is an integer as well. So next one is minus 20 plus 0, which is 20 minus 20, because 20 is the greater number when you compare to 0, and 20 has the negative symbol. So this one is also an integer. So the last one, we have 35 plus, minus 35 plus minus 10. So minus minus is plus. So we are going to add this. 35 plus 10 is 45. And which carries the highest symbol, 35, which is negative. So this one is also an integer. Okay, so let's see. What do you observe? Is the sum of two integer is always an integer? A sum of two integer is always integer? Yes, because when we add these two integers, whether it is positive integer or negative integer, when we add any integer, it is always an integer. So you have to add yes. So did you find a pair of integer whose sum is not an integer? So do you see any pair of integer when you add it, it is not an integer? For example, did you get any fractions, or you got any decimals, or you got any percentages? Nothing, right? So we didn't get any. So you have to mark no. No, we did not find a pair of integer whose sum is not an integer. Okay, so do not worry about this, students. When I prepare a worksheet, I'll be asking many questions, so it will be very helpful for you to practice. Okay, so since additional of integer gives integer, we say integer are closed under addition. In general, for any two integer a and b, a plus b is an integer. So this one, a plus b is an integer. Okay, for example, if you have a is equal to 5, b is equal to 2. So when you add a plus b, which is 5 plus 2 equal to 7, 7 is an integer. Okay. So next one, we have completed addition. So next is subtraction. Okay, closure under subtraction. So what happened when we subtract an integer from other integer? We can say that there is a difference is also an integer. So difference is like subtraction. So observe the following table. So we have completed addition. So next, see whether when we subtract, the result is an integer or it is not an integer. Okay, so they have already given the first one. So 7 minus 9 is 2. 9 has the negative symbol, and 9 is the greater number when you compare to 7. So they have taken the 9's sign, which is like minus sign. Okay, so next one. So we have the first one as an integer, second one is 17, and we have minus and minus 21. So minus minus, that will go plus. So we need to add this 17 plus 21. So 17 plus 21. Okay, so 7 plus 1 is 8, 2 plus 1 is 3. So 38. So 38 again an integer. And minus 8 minus 14. So minus minus plus we have. So here we have one more minus. So we need to minus this out. So 14 minus 8. 14 minus 8 is 6, and when minus minus gone plus, this symbol will go plus. So the greater symbol is 14, which is the symbol of the result as well. So the result of an integer is integer. So here we have minus 21 and minus and plus 10. So this will become plus because minus minus plus. Then we have to subtract. So subtract 21 minus 10. So 21 minus 10 is 11. And here which one has the biggest symbol? 10 has plus and 21 has negative symbol. 21 is the greater number, so you take negative symbol from here. Okay. So next one we have 32 and minus minus plus now. So we have to add these numbers. So 32 plus 17. So 7, 8, 9 and 1 plus 3 is 4, 49. So this is plus 49. So everything we are getting integers. So again integer. So we have 18, 18 minus minus plus. So minus 18 and plus 18 will go as 0, which is also an integer. Okay. So next one we have like minus 29 minus 0, which is anything when you add or minus from 0, you get the same number. So the greater number minus symbol, this one is also an integer. Okay. So what do you observe? Is there any pair of integer whose difference is not an integer? No, because we got all the numbers as integers. Okay. So we can say integer are closed under subtraction. Yes, we can see that integer are closed under subtraction. Thus, if a and b are two integer and a minus b is also an integer. Okay, do the whole number satisfy the property? So they are asking, for example, we have a whole number, for example, 5 minus 7 is minus 2. Yes, it solves the property as well. So here we have integer, for example, a minus b is equal to 7, and if we have b is equal to 1, and a minus b, which is 7 minus 1, 6, which is also an integer. Okay. So integer is very easy, children. So you have to concentrate and try to practice more sums. It will be very easy for you. Okay. So let me erase all these. Okay, next we have commutative property. So commutative property, we know that 3 plus 5 is equal to 5 plus 3 is equal to 8. So that is the whole number that can be added in any order. In other words, addition is commutative for whole number. For example, so if you have any number, 8 plus 1 is equal to 9. 1 plus 8, which is also 9. Correct? So 8 plus 1, which is equal to 1 plus 9. Okay, so that is the thing they are telling. In other word, addition is commutative for whole numbers. Okay, so can we say the same for integers also? So can we say same for integers? For example, we have 5 plus minus 6 is equal to minus 1, and minus 6 plus 5 is equal to minus 1. Yes, it is same. So 5 plus minus 6 is equal to minus 6 plus 5. Let me show you another example for integers. Okay, okay, if you have like 5 plus minus 2, which is equal to minus 2 plus 5. Both are same. So 5 minus 2 is just equal to 3. And minus 2 plus 5 is also equal to 3. Okay. So both are same. So it is same for integer as well. Yes, it is same for integers as well. Okay. Are the following equal? So are the following equal? So minus 8 plus minus 9, minus 9 plus 8. Yes, these are equal. And when you see this one, minus 23 plus 32 and 32 plus minus 23. Yes, because we just saw this one, right? So last one, minus 45 plus 0 and 0 plus minus 45. Yes, it is also same because minus 45 plus 0 is equal to minus 45 and 0 plus minus 45, which is also minus 45. So these both are same. Okay. So try with 5 other pairs of integers. Do you find any pair of integer of which sums are different when the order is changed? Okay. Now they are asking to do with any 5 integers and they are checking whether the pairs are same if we change the order. Let me erase all the things. This is very simple. Okay. So let me change some other color to blue. Okay. So I'll do maybe two pairs. Okay. So this is the first pair. So I have minus 2 plus 7, which is equal to 7 plus minus 2. Are these same? Let's check. Minus 2 plus 7 is equal to 5 and 7 plus minus 2, which is also equal to 5. Yes, both are same. Okay, so did you find any pair of integers sums are different when the order is changed? No, we did not find any. Okay, certainly not. Yes, we say that in addition the commutative of integers. Okay. So in general for any two integer a and b, we say a plus b is equal to b plus a. Okay. For example, 5 plus 10, which is equal to 10 plus 5, where a is equal to 5 and b is equal to 10. So a plus b, which is equal to b plus a. Okay. So we know that subtraction is commutative for whole number. It is commutative for integers. Yes, it is commutative for integers as well, like we did for addition. For subtraction also it is the same. Okay. So consider the integer 5 and minus 3. So 5 minus minus 3 the same as minus 3 and minus 5. No, because 5, if you add this, it will become 8, and this one minus 3 and minus 5, you will get minus 8. Take at least 5 pairs of integer and check this. We conclude that subtraction is not a commutative property of integers. It is not a property of integer. Okay. Because here when you add it 5, so minus minus is plus, so you will get plus 8, but when you subtract minus 3 minus 5, you need to add it, which is 8, and you need to take the greater symbol, which is 5, which is minus 5. Okay, so that is the reason it is not commutative for integers. Okay, let's see the associate property. Okay, so now we have completed the commutative property of closure, subtraction and addition. closure under addition. Okay, let's see whether we can able to complete. We still have associate property and we have additive identity. Okay, later on once we complete that, we will go to like example 1 and exercises. Okay. Okay, so we still have many to complete in integer. We will see like one by one. All right. In next class we will see from associate property. Okay, we will see from associate property. And students, if you have any questions, do send me an email and let me know, and join the channel. Okay, you have to join the channel to receive the worksheet through email. My email address is already there in the description box. Okay, take care, be safe, and you have to practice more to get good marks. All right, so next class we will start from 1.4, which is associative properties. All right, and then additive identity, followed by the example sums. All right, and exercise starts. Okay, students, you all be safe, take care, bye bye.